Zach Henderson. I work as a solution engineer at Catchpoint, and I'm here to kind of give you a quick demonstration of all the things that Tony has been describing with some kind of representative use cases of using the platform an actual person, kind of see through the UI, see through the graph, see through the data, and help you understand it. Okay, so with any good demonstration, just like you look up on your map, you say, hey, I want to go from here to the airport. You kind of tells you how you're going to get there. So I'm just going to give you a quick guide of what I'm going to show you today in terms of demonstration, which is pretty much what Tony was describing, right? Oh man, a user complains or you have a poor experience. Oh, this website feels slow, right? And then there's a set of metrics out there about user experience, like time to first render, time to first byte, time to that nice, pretty landing marketing page showing up when people go to the site. And those are metrics that talk about user experience, but there's a lot behind the scenes in terms of perspective. You know, how's the network carrying the traffic? How's the application responding? And so going from this website or this application feels slow to understanding the KPIs that are changing on that site to actually understanding the full stack of how that system's working from that particular perspective. That's kind of what we'll cover in the demonstration. And we'll even go as far as kind of correlating that slowness. So, oh, that slowness, okay, the website, the application feels slow. Here's the latency perspective from the network. Here's how many hops away that individual agent's reporting in, or that user's perspective. And we'll kind of go from a multi-layer correlation view of your site's availability, site's uptime, its user KPIs in terms of performance, the application response time, and probably most importantly for this group, how is the network looking at that given time, right? So to reduce that kind of finger pointing, or not kind of get that contributing cause faster for a lot of these scenarios, where time is money, for downtime or slowness events, having a kind of multi-layer perspective of that to go from user experience to the individual KPIs of that service is kind of what we'll go into. And then we'll talk about how to use this data, how to determine is that an anomaly, is the internet just having a bad day, or are there things that you can do to improve the service to get that system back in line with expectations that the business has set as a whole. And kind of talk about how this compares, right? Is that slowness of the application, is that localized to that part of the US, that part of mainland China, that individual provider, like the Vodafone example that Tony was saying in India. So we'll kind of go through that and kind of go through a few of these screens that you see here as part of the demo. And eventually we'll get to a nice fancy graph of how our agents see traffic hitting different services around the globe. So just a little tease there in that case. Great. So let me get started here. What I have is just the Catchpoint homepage and some use case that we can all talk about. You know, I want to go ahead and look up the local weather of where I'm living, right? So I prefer going to the NOAA.gov site, and that's a pretty fast experience. I don't have a slow experience of visiting this, or if I type in and say, hey, I want to find the local weather from where I am, right? That's an experience of a digital interaction that we all do on a day-to-day basis, whether it's talking about the weather, booking an Uber, joining a Zoom meeting like we're on right now. But this is just my perspective from this individual location in which that experience is had. Globally, when this happens, you might see things like this, right? Which is waiting 8.5, 9.5, 10.5, 11 seconds just for that kind of background image to appear. And these are things that users would complain about, right? Oh, the application's slow, I can't interact with it. And so from a optimization and troubleshooting standpoint, is this the network's fault? Is this the application's fault? Is there something else going on in terms of that delivery chain? Is it more about what you're delivering versus how it's being delivered? So many questions kind of come up, right? And so a lot of times people will say, well, this is a tool set for some sort of website performing profile, just in this case, web page test, if you've ever heard of that system. It's another part of the Catchpoint ecosystem where it'll kind of give you say, hey, visit this URL, visit this stat, and give me a set of performance data directly from the browser about our site's first byte time, our site's rendering times, the KPIs on user experience that Google is using to rank that site, and highlighting, hey, like the LCP, or largest contentful paint time for a metric, is pretty high in this case. And that's actually where I got that little GIF here of a slow measurement, right?
What largest content, what was that?
So Google and its search rankings will kind of quantify people's sites experience. And they base it off of a few metrics that they call web vitals. So LCP, or largest contentful paint. When you visit an application, it's like the main image or the main block of text. Or if you're trying to go to the New York Times, it's like that main article.
Oh, gotcha. Okay.
So that's what people talk about when they talk about slowness a lot of times. But this right here, this is just one test run. I hit go and I'm measuring it from a single perspective. It's really no different than opening up the developer tools in my desktop here, laptop actually, and making some sort of performance measurements and so forth. So what the system does, that network that Tony's been describing in the Catchpoint active measurements, this right here is the actual Catchpoint UI, where from around the country, I'm actually visiting that same application. I'm saying, hey, I want to look up the performance of this weather site or this application I'm measuring. And as you can see, we're measuring it from Las Vegas, we're measuring it from San Jose, Seattle, Portland. And those line items here that you see, kind of this Portland, AWS level 3, CenturyLink, Comcast, that's that single kind of looking glass perspective from those network providers in that market. And what we're doing here is actually giving a trend across all the different performance values. So if I kind of zoom out here, you can see we're actively looking at and analyzing, A, is the site down or available? This kind of low downtime component that you see here. What's the response time or the impact of the site's performance from the DNS layer? Is it taking a long time to resolve that domain? Is that kind of causing that first byte issue? Or what's the impact in terms of is there packets being dropped when hitting that front end IP address that we're connecting into? Is there high latency changing over time? Is it taking long to form TCP connections to that IP address from these external vantage points? And how does that correlate to things like the overall page load time, overall markers of those metrics like largest contentful paint I measured, which talk about user experience first. And so here is kind of this concept of taking all these type of different vantage points and saying, here's the perspective of these different layers that are involved with that user transaction of just simply visiting that site to look up the weather. And what we can actually do with the system here is very quickly kind of go in and say, I know that things are complex. A service does not, if I told you the site loads in that 10 seconds, well, that's just a calculation or maybe an average across multiple different test runs. The service actually will tell you, from the perspective of Portland on Amazon's network at this individual time, that application loaded in 7.4 seconds. At the same time, from Miami on level 3, that loaded in 3.1 seconds for a page load experience. So there's a distribution in terms of across the country, across different network providers, across different regions. And that's what this is trying to show you here in terms of our measurements. How is this looking like from actual users' perspective 24/7, with the idea that this will generate alerts and alarms if there's outages, if there's performance degradation, and allow you to kind of drill down into this further. And so the concept here is that if I see like a failure, like, hey, there's a little red diamond here indicating a failed measurement, that site is not available for some reason. And we can kind of very quickly go into our results and say, from the perspective of level 3 in Las Vegas, trying to look up that site, there was purely a DNS failure. The site can't be reached. Imagine showing someone trying to go to your application and you got that message, right? That's a DNS failure. Or this could very quickly be something like slow experience where I actually go into the service and say, how's the weather in Honolulu, right? Maybe I want to plan a vacation. But imagine if I tried to look up the weather and that took roughly 5-6 seconds for that to load. That's a kind of experience measurement that we have here where we can start to quickly correlate and say, from the perspective of a market like Honolulu, using a real Chrome browser, this is an active measurement that took place in that large data set that I was talking about. And we can quickly go into this and say, show me requests that are taking a long time to load or requests that have a long time over the network. So in this case of individual HTTP transactions of loading an application, are bottlenecks happening with that main marketing image because of high DNS query times, high TCP connection times? In this particular case, this kind of blue bar you see here, this is actually showing that it's taking roughly 2 seconds just to load a single image over HTTP2 from that perspective of this vantage point in Hawaii.
Could you go back to the
Yep.
lines on the right-hand side and just kind of break down what
Sure.
information we're looking at in terms of, like, there's the navy and there's the red and
Yeah, yep. So in this case, this is an application HTTP perspective. So when you visit a website, you're making hundreds of HTTP transactions to different services and systems. And what we're kind of detailing here is that there's a certain phases of an HTTP transaction. There's the DNS lookup time, if it hasn't been done before to that domain. There's the connect time in yellow. In this case, there's no need to form a fresh connection for this asset. And then there's a few other components like a SSL negotiation, wait time, or backend server time, so long as it takes that backend to process that first byte of data. And then there's this last component, load time, also known as time to last byte, essentially, where kind of the main reason this image took roughly 2 seconds to download from this perspective was because it was taking 1.9 seconds to download that image fully. And so this is kind of that application layer running over the network. And so at the kind of correlation view, if I want to see the path that the service is taking from Hawaii to get to the server, the kind of front end delivery mechanism, whether it's you're going directly to an origin or you're going to a CDN provider that's kind of trying to get this content closer to the user. At the same time as that waterfall, we're actually doing a simple ping and trace route to kind of measure latency, measure network path, measure the hops involved. We can actually kind of investigate, it took roughly 14 hops to talk to the IP address that's mainly serving content on that website. It's roughly 51 milliseconds away, but there is some packet loss end to end, of which is originating kind of roughly 5 hops away from our probe on level 3's network in Honolulu. And then eventually it hits, in this case, AS 16509, which is Amazon's network. In this case, they're using Amazon's CloudFront service to deliver edge content closer to the users, for example. And so what we're kind of correlating here is that there's an issue on delivery of a service, in this case, packet loss from level 3's network carrying forward to the server IP that's processing that request, of which, that kind of manifests itself in terms of retransmissions, higher load times, things have to, TCP being a service that kind of cares about things being in order, that will kind of lend itself to higher load times, higher experience measurements end to end. So something as simple as this of saying the network's not, the application's up, people can get to it, but is it the best experience, best quality of experience? That's why people are probably working to get edge perspectives closer to Hawaii, closer to Honolulu, or going multi-CDN, multi-cloud providers, for example.
So obviously you're getting this data either from your browser agent or user agent, as you guys talked about earlier. Let's say that we've got this scenario going.
Sure.
You have with work from home, we don't necessarily have access to their PCs or whatnot.
Sure.
See exactly what's going on. Do you have the capability to tell us that they're on, say, for instance, we had a client where they had a C-level person who was rolling along, had no problem.
Yeah.
Then all of a sudden he has a problem for 4 hours, then he doesn't have a problem again.
Yep.
And we go back and look, and the smoking gun, so to speak, that we found was that his computer had switched from his home SSID to some neighbor's hotspot and then back again.
Yeah.
And his latency had gone from 30 milliseconds to 180.
Yep.
Do you have that?
Yeah, we do actually. So I can kind of divert here very quickly just to show you this, but this little applet that's on my desktop, it's doing a little quick network test here. This is actually a lightweight version of that agent software that's deployed in Hawaii, where from my perspective, it can run these type of ping, trace route, SSID checks of what perspective I'm connected into, and kind of tell me, hey, Zach, your device is connected into the field day Wi-Fi. It has this signal strength. You can have this certain internet speed test on demand. And then behind the scenes, what that does is actually runs these synthetic checks across, in this case, I'm just one employee out of hundreds at Catchpoint. That reports back into the same type of reporting engine to then say, show me the global perspective of our user base who has this agent installed. or zoom in on that VIP or that user that's raising that support ticket and actually kind of highlight it down to their individual perspective, like at any given time.
Yeah, and actually it will capture SSID or BSSID and
That
also
was
signal
my-
strength.
That was my next question, was
Yep.
BSSID and signal strength, because we've seen that too, where they have
Yep.
one AP in one side of the building, one AP on the other side, and they've suddenly moved just enough to switch to the other one, and they don't have as good a signal, and
Yep.
you know.
And you got Macs around. I see that a bunch of people have them. Sometimes they don't let go of the BSSID that they're attached to soon enough, right? They'll wait until the signal strength gets way weak before they'll transfer to the stronger signal strength. So you see that a lot. And we have a tool that will help with that.
Awesome.
Yeah, just a quick perspective of that. This is actually my device I'm giving you this demonstration on, that little applet. It's reporting in and telling me the health of my overall experience out of 100, the health of my endpoint, in this case, what my utilization and memory usage is. It tells me that I've connected into a few different Wi-Fi points on this travel journey I've had here over the past 24 hours. Field day Wi-Fi, Hilton Honors Wi-Fi, the channel strength and the band I'm on. And it kind of puts this in context of, at one point I was traversing over AT&T, and then I switched network providers and I have a different perspective. And how does that correlate to the health of my Wi-Fi I'm connected into, the health of the network I'm on, the routes taken from my device? So all those graphs that you've seen from these different perspectives, you can do it from an individual user as well.
From that individual user's perspective, let's say they're work from home.
Yep.
And they're VPNing in, and
Yeah.
it's slow, but you're in an area where, hey, these neighborhoods have AT&T and these neighborhoods have Comcast, and oh look, it's a Comcast issue.
Yeah.
Can you elicit that data without having to jump through too many hoops?
Yep. So from a kind of global perspective, I can kind of switch context here and say, show me, let's say people are complaining about Microsoft Teams, for example. I can measure from 219 endpoints here, over 15,000 measurements over the past 24 hours, the average latency to Microsoft Teams infrastructure of 35 milliseconds and roughly 2.3% packet loss, down to each individual employee that has that agent installed, or across all the different ASs that they're connecting into, and even down to individual cities. And I can filter to say, a lot of users are complaining in the, say, India market. I want to filter down to their perspective and show you all the different networks and ASs they're reporting into, as well as build out that end-to-end path diagram of, from agent software, here's the bottlenecks that people have when hitting Microsoft's network here, for example, and it's only that individual user that took that path to get there. So this agent software comes in that kind of lightweight endpoint perspective that we have here. And also what we were showing before is that those kind of dedicated 24/7 probes running on Comcast network, on Vodafone's network. Because the kind of trouble with an endpoint software is that it's only as good as when the user's device is turned on.
Right.
Right. It's kind of hey, if the user's device is turned on, I don't know in the morning if Teams is going to be working for half the people who are coming in from Comcast, for example.
And if it can't phone home, it saves the data and uploads it later.
Yep, it's kind of designed to report in to our global infrastructure and allow you to see when users' devices are turned on, things of that nature.
And obviously you can go in here and say, my problem was between noon and 1. And
Yeah, we actually store a lot of our data unaggregated. So if I go back into that system here, so all those measurements that we talked about with analytics, you want to have that kind of raw data to look at those outliers, look at those. I'm in a different vantage point here. So yes, we keep that up to 3 years, actually unaggregated. So you can say, show me the 99th percentile, the 95th percentile, see how my things are looking like from different perspectives on demand as needed. And from a presentation and analytics layer, we can take that telemetry and we can quickly overlay it on pretty graphs. If you have to, this graph I'm going to show you here was a favorite of, I think, the CTO at Washington Post. He liked to be able to see where user traffic is coming from around the globe and how it's hitting their infrastructure, and kind of highlighting, hey, from from China, it's going all the way across the US and hitting a server in the West Coast of the United States, but then that's a different perspective from different ISPs in that market. And the system really kind of builds these type of graphs for you on demand off of that raw telemetry. And then very easily allows you to deep dive into say, here's the perspective of our, let's say, content delivery network from China, showing you that Amazon is always going to Singapore, for example, is kind of SIN, no ID here. Whereas like China Mobile is actually being served from NRT, which is a indication of like Japan, I think Tokyo in that case. So for any cast networks, for any sort of global routing system that's highly dependent on peering and things of that nature, kind of having this telemetry to say these systems that are delivering assets, they can behave differently. And is that happening in moment or is that happening consistently over time for each measurement that you make?
You might have answered this already, but do you have the ability to look at relations between like a single public endpoint and all other public endpoints?
So kind of saying from the perspective of, can you have an example perhaps?
Yeah, like say, we're in Azure North Central, right?
Okay.
And we want to see, because of our hybrid workforce, we want to see what all the other regions across the globe, like all the ISPs across the globe, what the reachability is to Azure North Central.
Yep. So we, given the kind of perspective that we have, those major cloud props and different carriers, I could say, I want to make some of these active user experience network measurements from different Azure regions and point them towards other assets of interest. So whether they're kind of two nodes talking to each other, we have this kind of concept of a node to node test. They can kind of ping each other and measure the latency and path between each other. Or you can say, I want to test towards 8.8.8 Google. I want to test towards Teams. I want to test towards Salesforce, other systems that our employees use. And these are not only just kind of trending charts that are running behind the scenes. It is kind of that looking glass type look to say, I want to target an IP over on the port 443. And I want to run that from this agent, this agent, this agent. I want to hit run test and kind of have like an on-demand perspective if I'm trying to troubleshoot something right now. So say, I'm trying to figure out, is there any reachability issues from San Jose and AT&T's network? This is kind of like hit go, make a measurement, make a test, and you can see that kind of issues going on at that moment. This could be across network path, ping, DNS queries, IoT, MQTT type testing, a lot of different things like that. All those different monitor probes that Tony was mentioning beforehand.
Can you hit this page from an API, like outside system?
Yeah, so actually all the data screens that you've seen so far, we can stream that data to you in real time. You can query it via REST API. There's a whole programmatic interface to say, run a test now. I want to have a bot in Slack or ServiceNow that when we get a ticket, it runs some basic checks.
Right.
All those things can kind of automate in that sense.
Right. The ticket comes in and then it submits all the required data to that page and gets the test results back.
Yep.
So you've shown, like AWS and the cloud providers and that stuff that you've got points of presence there.
Yep.
What about the SASE or whatever we're calling it this day of the week?
Sure.
Umbrella.
So like
Zscaler.
Cisco Umbrella, Zscaler, Palo Alto, Prisma.
Because we're seeing a lot of that where our customers buy that service, they run all their stuff through, and then realize, oh my God, our performance sucks.
Yeah.
For whatever reason, it's usually because of antiquated old, SMB based stuff. But we have to be able to prove, the point. So is that something that you have points of presence?
So we don't necessarily have points of presence on like Zscaler or Palo Alto's network. We are in the same cloud regions a lot of times that they're deployed in. But that endpoint agent, this little applet that you see here, if I were to run Zscaler on my device, or if I were to run other SASE-based services like Warp from Cloudflare, for example, it picks up that my traffic is traversing over that network.
Okay.
And as a global enterprise, you can say, show me the performance of our traffic that's split tunneled off of the service. Show me which route or POP people are coming to us from. And I have some screenshots I can probably bring up, but it's like we can see 25% of your workforce in India is being served from the Zscaler Mumbai POP. They're having issues connecting to that region, and then their traffic traverses out there, and that's kind of the issue they're having with Salesforce or Teams in that case.
Okay, perfect.
And so a lot of this telemetry, it's shareable. You can export it, and you can, those providers actually use Catchpoint behind the scenes a lot of times, so they can understand the telemetry. They can say, hey, I have that Catchpoint data. Send me the public link, essentially, or show me the link. And you can kind of have that on demand to share with them.
Web is all great and wonderful.
Yep.
But do you cover other applications?
Yep.
For example, he mentioned SMB. Now, generally, that's more of an internal protocol, but
Sure.
People getting crazy and hosting stuff in the cloud, which they don't realize is very far away.
Yes.
One of the classics that we have is that's where they ended up putting all the drives, and people map a drive and they're wondering why it takes, 10 seconds for a directory structure to
Yeah.
show up. So do you have anything that does that kind of?
Yep. So not out of the box, but these private agents that you deploy, you can think of them as programmatic agents. You can upload your own code to those boxes and say Catchpoint, execute it. So we've had customers that will have it talk to an IBM mainframe and say, hey, talk to this mainframe, make sure it's up and responsive. That's not something that we built ourselves as a monitor, but they scripted out like a little Python library or C library to talk on that specific protocol. And we then parse out the stats from their output on that. So it's extensible in that regard.
Yeah, and from my experiences, what I'm looking to prove
Yep.
is that it's not necessarily the network.
Yeah.
99% of the time, it's an endpoint problem, and I want to be able to prove it's an endpoint problem, not,
And sometimes the answer too is that we know we're not going to solve all the problems with this. We get closer to the edge, closer to the user for you. And then our data can be piped into other systems that you have, whether it's a Splunk, an Elastic engine, and some sort of data lake, data warehouse to also correlate in that regards.
Can this agent test like the internal applications to the point of confirming you can log in on a page, that kind of thing?
Yeah, so this actual little user transaction here is instead of visiting just the landing page, it can also say, hey, go to the page, click the login button, sign in with some test credentials, verify that the weather shows up with the correct information. For a lot of the employee-centric use cases, we do work with like single sign-on. So if someone has like Microsoft Azure as their identity management, and go to that page, sign in, launch Teams, launch Zoom, and kind of go through that workflow end to end.
And can I put the agent on something like a Raspberry Pi at remote offices, that kind of thing?
So it's deployable either as a VM virtual appliance, as a container. So a lot of times we either provide the hardware, or you have kind of installed it on a CentOS or Red Hat box that you own. From a Raspberry Pi perspective, we're not quite there yet. Chrome takes up a lot of resources for those type of higher end user transactions.
What about running it on one of the various network switches that support?
Yep, that is something we're still actively working on. We have had some success. We're running on Cisco gear in that case.
Yeah, I mean, this looks really, really interesting.
Sure.
One of the things that keeps crawling in my head, because I'm a Cisco partner.
Yeah.
What differentiates you from Thousand Eyes?
Sure.
So show me what's new and different.
We have more than 1,000 eyes.
Yeah.
You know, 1,024.
You just made our CEO very happy by saying that.
Yeah.
So that is true, right? It is more than 1,000 eyes. Sorry. It's
Probes.
from a quality and clarity of data points. That single home perspective provides a lot of that kind of crystal. So hey, it is Telia and that graph that's having an issue. A lot of synthetic providers out there will host these just in Amazon or in hosting providers that have that multi-home type perspective, where it's saying, hey, multi-home is great for resiliency and reliability of connections, but from a monitoring perspective, that adds some fuzziness to your data. And that's what we see a lot of times with providers like that.
Okay, fair enough.
And then from the analytics and kind of data quality, all those scatter plots, those kind of deep dive things, we built a purpose in-house engine just for that type of storage and analytics of that data. Very quick answer, but there's definitely more to it.
Question for you, and it's kind of starting to come together in a difference between monitoring and observability, at least on, because we started at the beginning saying, oh, we're saying observability because we're sick of saying monitoring.
Yep.
What I haven't seen, and tell me if this is possible or not. So from here to there, my experience has changed, and you can tell me, oh, you're taking a different path now, and that path is injecting more latency into the transaction.
Yep.
But you're not telling me that my BGP neighbor went down.
Yeah.
You're just telling me that the experience has changed, and you can show that it's a different path.
Yep.
But we'll just pretend that it's entirely internal to my environment, and I control every router between point A and point B. You're not saying you lost your neighbor. So monitoring still has a home out there to let you know a service has crashed or a neighbor has dropped, but you're at least letting you know that the experience has changed.
Yeah, so we actually do get to that BGP piece. I just haven't covered it yet. But
Okay.
yeah, so you'll see up top here, I actually cover it later in the presentation. There's a routing tab. So if you give us your external prefixes that you're announcing, say, hey, we have these peers with Comcast and Level 3 and AT&T. If we start to see a change in that network path, that change in that experience telemetry, we can go in. I'll show you in just a sec. And there's a bevy of announcements or withdrawals, or those prefixes aren't reachable from that market. You're being hijacked.
And maybe BGP is too easy because that we're saying, okay, that's observable from a looking glass or from anywhere. But I'll go back to it's internal, and I'll say it's OSPF or it's EIGRP. Like I've had my routing process break. So you can observe that routing has changed, but you're not observing my routing process.
Correct. Yeah, I mean, like this does not replace any of the internal, like I said, streaming telemetry or SNMP data that you collect today, or the stuff that you're collecting from your network gear. You might be screen scraping, right? We don't know, but all this data complements each other, right? So being able to pull this data into a common system like an Elastic or or Splunk and be able to cross correlate the data, super important, right? Like this is just another signal to tell you, hey, something's changed. Because if EIGRP changes or OSPF changes on your side, you're not necessarily going to get an alert, right? And you're not necessarily going to say that there's been a performance change, things have gotten slower. It's not going to tell you that, right? We know that. What this does is just to add another layer on there for something you to go look at and say, hey, the path has changed. Check your tables. Did something change on your side? Did a link go down? Did a metric change? Did somebody push a change, right? That caused metrics to change, that caused your routing table to do something different.
Do you have any, I'm guessing it's not there, but any plans to introduce any kind of correlation engine, or would you rely on somebody else? Like that other people do that better and we're not gonna get into that.
You know, if we were like a 10,000 person company, maybe, or a 300 person company, so that would be really hard to do. But yeah, I mean, that's the ideal dream, right? And especially like if you have an event trigger on your network, the fact that you can then go do an API call to us automatically, like within a ticketing system to say, oh, okay, this changed. Let me see if it had an impact, right? And then be able to go run an instant test on any of these nodes, whether it's public or private, right? So you can say, no, that shouldn't have affected my user base, or yes, this affected my user base. I got to dig into this. This is now a P1 or a P0 instead of a P2 or P3, right? This just helps you build a picture of what the impact was.
Right, cool.
And you seem to have a focus on internet and public resource traffic overall, which is often the most difficult for us to troubleshoot because I don't have visibility on the inside of what's going on.
But like I said, all this stuff becomes private because usually what we'll see is people will multi-layer, right? So you have a remote office, you put in a physical probe because that probe's 24/7, right? So or run it on a 9300 Cisco 9300, right, as a VM. That's running tests all the time. So now you know what your steady state is, right? Like this is what it looks like every 5 minutes for the last 2 years, right? And you can see the changes as people come into the office and start going. Like that was one of the problems I was trying to solve with Google was, how can I guarantee when nobody's in an office that when somebody steps into that office, everything works?
Yes.
Video conferencing works. They can get to the resources that they need to get to. The problem is network telemetry doesn't tell you that. I can see
Devices.
that router's up, cool, switches are up, great, but it doesn't tell me, right, that video conference will work and will work well, or that it's being sent to the right, like all these SaaS applications, because, you know, I can run a Starbucks for my office network, right? Because all our applications are SaaS. Right. So I don't have any internal corporate resources that people need to get to, file shares or whatever. We use OneDrive, we use Outlook, or we use Google, you know, and Google tools. So that doesn't matter anymore. But now what matters is that office getting sent to the right location, right? That gives them the best performance, right? And you need to be able to know that. And network telemetry from a switch or a router isn't going to tell you that. Right. So this is just an augmentation onto the monitoring you already have in place. Right. So take advantage of it.